We are today going to understand first come first served algorithm. So these are the different types of scheduling algorithms that we will be studying in this chapter. So here, as I have just told you, first algorithm that we are going to study is the first come first served. Then second is the shortest job first. Third is shortest remaining time next. Fourth is round robin algorithm. Next is priority scheduling. Next is multi-level queue scheduling. So these are the 6 algorithms that we will be studying here. So let us start with our first come first served algorithm. Now here, this is a very simple type of scheduling algorithm. Now whenever we go to, say suppose a movie theater, or we go anywhere, right? India is a very densely populated country. So wherever we go, there is always a queue. So suppose say a queue is there, and then what happens is that as per the person is present, right? Now suppose this girl has arrived first. So she gets the chance first to do whatever the work she wants to do. After this girl, this second person will get the chance. Then this third person. So likewise, means here what is the logic is that suppose all these different kinds of people have to do a particular work. So they are going to arrange themselves in queues, and one by one they will be processed. Now if you just replace these people with processes, now we know that in operating system, multiple processes are going to come into the system. So consider these people as processes. So what happens in first come first serve scheduling algorithm is that whichever process comes first in the system gets the chance of getting the CPU. Now consider this person as, say suppose, CPU. Because we know that for execution of any process we require the CPU, isn't it? So in first come first serve algorithm, what is going to happen? Multiple processes will come into the system and they will be provided the CPU as per their coming into the system. Means if P1 has arrived first into the system, that person or that process will get the first CPU. After P1, P2 has come into the system, so next he will get the chance to the CPU. So in this way, first come first serve algorithm is the simplest one, and it provides the CPU to the different processes depending on their arrival time. So let us understand how actually this first come first serve worked. As I have told you, first come first served is non-preemptive. Means what? There will not be any interruption while the process is being allocated the CPU. And which process will get the first CPU? Whichever comes first into the system. Now, as I have told you here, jobs are scheduled on first come first basis. Means if process P1 comes into the system, then that process will be executed first into the system. Now, once the process starts coming into the system, then it's PCB. You recall what is PCB? PCB is the process control block. It is connected with the ready queue. Now we know that whenever the process comes into the system, first the long-term scheduler puts it into the ready queue, isn't it? And from ready queue, the short-term scheduler then gives the processes to the CPU, isn't it? That we have already discussed. So in first come first serve scheduling algorithm, the processes are allocated CPU on the basis of their arrival time. Now, this particular FCFS is very simple to implement, but its performance is very poor. Why? Because here what is going to happen, since there is no preemption, means the CPU and IO are not effectively utilized in this method. And how we are going to judge this? For this particular algorithm, hence onwards, we will be calculating the waiting time and turnaround time, and then you can easily see that why we are saying that first come first serve performance is very poor. Because suppose process P1 is there, okay, and it is having a very long burst time. So once it gets hold of the CPU, it is not going to release the CPU, and maybe then suppose say that particular process may go into waiting for some IO operation. So in that time what will happen? The process P1 is doing the IO operation and CPU is idle. Because why? Since P1 is being allocated to CPU, other processes will not get the chance for execution. So hence we are saying that its performance is poor. And we will see two measures, waiting time and turnaround time, to understand this concept. Okay. So this was the explanation for first come first served. Now hence onwards we will be solving some numericals to see how is the performance of the different algorithms that we are going to study. So first we will take some example. Now you remember that in a MSBT question paper you will be given such types of problems, okay? And they will come for, say, suppose either for 4 marks or the 6 marks depending on what they're asking. Now if you look at this particular example, so here in the system 4 processes are coming, and their arrival time is mentioned here, and the burst time means here how much time each process is going to utilize the CPU. So this is the CPU burst time. And what is the problem statement here? Calculate average waiting time and turnaround time of above processes using first come first serve algorithm. First, for actually showing this waiting time and turnaround time, always remember first you have to start with the Gantt chart. Now Gantt chart means first you have to graphically show how much time each process is taking and at what time it has started. So first say suppose now process P1 is there. So it came into the system at 0 millisecond. And how much is the burst time? 8. So first P1, its starting time is 0, and since this is non-preemption, means what will happen at 0th millisecond only P1 was there. But at the next millisecond P2 has arrived. And if you observe the burst time of P2, okay, it is smaller than the burst time of the P1. But what is happening is that in first come first serve, as I have already told you in the discussion, that this is the non-preemption approach. Non-preemption means what? If a current process is being executed, now currently in this situation P1 was being executed, so it will not be interrupted. Even if the P2's burst time is smaller than the P1 process, still it will not be interrupted, and this P1 will completely utilize the CPU to execute itself. So for 0 to 8 millisecond, this P1 will take control of the CPU. Now after P1, next process that has arrived is the P2, and its burst time is 4. So it will be represented like this. Means it will start at 8 millisecond, then it will end at the 12 millisecond. Means 8 plus 4, 12 millisecond, it will terminate. Now afterwards, next process is the P3. So P3, it will start at 12 millisecond, okay, and its burst time is 9. So 12 plus 9 is equals to 21. So it will end at 21. Then next process, it will start at the 21 millisecond, and since the burst time is 5, it will end at the 26. So this is how the Gantt chart is to be drawn for every problem that will be given in the exam. Okay, mostly 2 marks are given for this Gantt chart first. Now next we have to calculate average waiting time. For calculating the average waiting time, first we have to calculate the waiting time for each of these 4 processes, and then we will take the average of it. So let us first try to calculate the waiting time for each process. If you remember the definition of waiting time, right? Now here this particular processes are entering the system, and one by one they are being allocated the CPU. So how much time a particular process is going to wait for the particular CPU is nothing but the waiting time. So how will you calculate the waiting time for process P1? Now process P1 entered the system at 0 millisecond, right? And immediately it was given the CPU. So waiting time is 0 minus 0. So P1 did not have to wait for the attention of the CPU. As soon as it entered the system, it got the CPU for execution, isn't it? Then let us observe the P2. Now P2 arrived in the system at 1 millisecond, but when it started executing 8 millisecond, isn't it? So waiting time will be 8 minus 1, isn't it? Hence I have written here 8 minus 1 is equals to 7 millisecond. Now you observe P3. It started at 12 millisecond, but when it has entered the system at 2 millisecond. So how much will be the waiting time of process P3? 12 minus 2. So it will be 10. Now consider the last process P4. So here it started executing at 21. This is the start time for execution of process P1. But when it has entered the system at 3 millisecond, isn't it? So it will be 21 minus 3. So it has to wait for 18 milliseconds to get the attention of the CPU. Now we have calculated the waiting time for all the processes one by one. And now next what we have to do? Calculate their average, isn't it? Average means what? I will just add up all this waiting time and divided by number of processes. So here I am going to add 0 plus 7 plus 10 plus 80. Means individual waiting time of each of the process divided by how many processes are there? 4. Addition comes out to be 35 divided by 4. So the average waiting time is 8.75 millisecond. So this is how the waiting time for this particular problem is calculated. Next, we are going to calculate the turnaround time. If you recall the discussion of how we have defined the turnaround time. So here, for solving the problems, I'll tell you one simple formula here. Turnaround time is equals to completion time minus arrival time. Completion time is what? Means the time at which the particular process has completed the complete execution. And arrival time is what? At what time the particular process has entered the system. So this is a Gantt chart as I have drawn earlier in the slide, and I have explained you how this particular Gantt chart is to be drawn. Let us now calculate the turnaround time for all these 4 processes one by one. So first we will start with the first process. Now observe this, at what time this P1 has completed execution? 8. At what time it has arrived in the system? 0. So what will be the turnaround time? 8 minus 0 is equals to 8. Isn't it? Now consider the second process. Here the process P2, here it completes its execution at 12 millisecond. And at what time it has entered the system? 1. So here 12 minus 1 is equals to 11. Then consider the third process. So at what time it has completed? 21. And at what time it has entered? 2. Isn't it? So 21 minus 2. So it is 19. Now observe this P4. At what time it has completed process? 26. And at what time it has entered the system? 3 millisecond. So turnaround time is 26 minus 3 is equals to 23. So this is how the turnaround time for each process is calculated. Now what next we have to do? Take the average. Again what I will do, just add up all these 4 divided by number of processes. So my average turnaround time will be 8 plus 11 plus 19 plus 23 divided by 4. So it will be 61 divided by 4 and answer is 15.25 milliseconds. So this is how the turnaround time for this particular example is calculated.